Good afternoon, everybody. I'm going to talk to you today about a couple of things that I think we should know. One of them that we're going to look at is conductivity and ionic compounds, and think about the difference between compounds, elements, and mixtures. So I'm going to talk about that. This is going to be probably a 2 or 3 part video where I'm going to look at different things to help us think about the difference between compounds, elements, and mixtures. We're going to start off by looking at them kind of visually, thinking about the atoms and molecules and what those things are. So let's go ahead and move on to the next slide here. All right, so I'm going to go through, I've got this entire set of pictures, these 9 pictures here. This is what I'm going to call Model 1. And Model 1 is showing different pictures. It's got, you'll notice there's some things within each box, there's a written code, and then there's some little bits of information that you see. So take a look at these things all throughout here for a second. And then we're going to work on answering the questions that are on the right. Okay. So give you a couple more seconds to look it over, kind of think about what you notice as you're doing this. All right, so the first question here, circle a model of RSQ in Model 1. And it asks how many atoms are in a model of in a molecule of RSQ. Well, I'm going to come here, and here I've got RSQ right here, right? So I can think about that and come down and look and say, okay, so I've got atoms and I've got a molecule. So okay, so I'm just going to circle this thing right here. That is a molecule of RSQ. And then how many atoms are in it? Well, if I look at this one right here, it's pointing once to the circle and once to the square, saying those are atoms. So I can look at this and say there are 2 atoms in that molecule. Next one, circle a molecule of TSQ2R in Model 1. All right, so I'm going to come down here. I'm going to look for this TSQ2R. And okay, I look, oh, right there, there's TSQ2R. So I know a molecule, looking at this so far, I know a molecule is something that is made up of multiple atoms. And I look down here, and all of these things here are the same. So let's maybe, if I do that, I circle that. That is a molecule of TSQ2R. So then the next thing, how many different types of atoms are found in a molecule of TSQ2R? So let's look at this. I have a circle, I have these 2 squares, and I have a triangle. So that's 4 atoms, but that is 3 types of atoms, okay? So I've got that. I've got circles, squares, and triangles. And then how many SQ atoms are in a molecule of TSQ2R? Would be 2. And so I look at this, I see 2 squares, and how do I figure out the squares are the SQ? Well, part of it's me just kind of like thinking, well, SQ probably represents like square, right? But I also look around and I notice, okay, so an R, when I have just R in the title here, it's just these circles. I have RSQ is a circle and a square. I have SQ2 is 2 squares together here. TSQ2R. So now me thinking about, okay, so what is the T got to be? T is probably the triangle, SQ is probably the square, R is probably the circle, so it's the round one, right? How many different types of atoms are found in a sample of SQ, R3, and TSQ? So I'm going to be looking, okay, here is SQ, R3, and TSQ. So the question is, how many different types of atoms are found in that? All right, so I've got triangles. I see triangles. I've got squares, and there's squares, squares there, and I've got circles, the round ones. I don't have any other shapes, so I'm going to say there are 3 types of atoms. And then how many different types of molecules are found in a sample of SQ, R3, and TSQ? Well, if I look at it, I've got this one right here, which is a triangle and a square together. So that's probably the TSQ. And then I also have this one right here, which is a square and 3 circles. That's probably SQR3, right? So when I look at this and I'm trying to think about this, I'm like, okay, so I have 2 types of molecules. And I'm going to include this 3 types of atoms, right? So this is one thing that we're thinking about. We're thinking about what is a molecule, what is an atom, how do we represent them, and we'll talk a little bit more about what these codes mean on the next page. So right now at this page, things I really want you to figure out: what is a molecule, what is an atom, and yeah, that's about it. So let's move on to the next page. All right, so when 2 atoms are touching in the drawings of Model 1, what is holding the atoms together? So I'm going to look through. I've got atoms, and then I notice, oh, this is pointing to where they're touching right here. And what does it say? Chemical bond. Oh, same thing right here, chemical bond. So if I'm going to try and figure that out, what is holding the atoms together? It's a chemical bond. Now, this is also asking us to think about particles. And particles are an important thing to think about because particles are what make up a substance. That's what I'll tell you right now. And I'm going to look at these and I'm going to say, okay, in this substance, it is made up of 8 particles. I noticed that. All right, so let me go ahead and underline that so you can see where I'm at with this. 8 particles. And if I count that 1, 2, 3, 4, 5, 6, 7, 8, right? So I've got 8 particles there for me to count off. And then I come down here, this is 5 particles. Well, there's more than 5 atoms in here. So 1, 2, 3, 4, 5. Okay, so what that means is that a particle can be an atom or it can be a molecule. So can a particle be a single atom? Yes. Can a particle be a molecule? Yes. It can be either an atom or a molecule. It is something that is separate from other things within this group, right? So these two are bonded together, so they form a separate group and they form a particle. So a particle can be an atom by itself, or it can be an atom bonded together. Or I can look down here, it doesn't have to be just 2 atoms bonded together, right? This one says it has 5 particles. Well, there's 1, 2, 3, 4, 5. All right, so there are 5 particles in this one. Some of them are made up of 4 atoms. Some of them are made up of 2 atoms, right? But they are the molecules. They are bonded together, held together by a chemical bond. All right, so now let's think about this. How many particles are in the drawing representing T and RSQ and R in Model 1? So let's find that. That is right here. And so I'm going to go through and I'm going to find, okay, a single atom by itself can be a molecule, or can be a particle, or a molecule can be a particle. So let's see, I've got 1, 2, 3 single triangles, 4, 5, adding in these single circles, 6, 7, 8. All right, so when I look at that, I see, okay, there are 8 particles in this. What do the letters R, SQ, and T in the codes represent? So I talked about this a little bit on the last page, but let's think about that. What's the R represent? It represents the circles. SQ represents the squares. T represents the triangles. They all represent atoms of a certain type, right? T equals triangles. SQ equals squares. And R equals circles. One thing I like to point out in this is like the periodic table. Sometimes the element symbol does totally match up exactly what you think it should be. So hydrogen is H, helium is He. Those make a lot of sense. But then we get to something like sodium, which is Na, or lead, which is Pb. And what we really need to think about is those abbreviations come from names of that element in another language usually. So another name for tungsten used to be wolfram, which is why its symbol is W. Another name for lead was Publius, I believe. I think I said that right. But that's why it gets the PB. So that's one thing we're thinking about here. All right, what do the small numbers subscripts in the code represent? So subscript means when you take a number and you lower it. You make it smaller or lower in place. So like this SQ2 right here, or like this R3 right here. And you know, this is, or SQ2. Many of you are familiar with the formula H2O, and you know if you see that written chemically, scientifically, there's usually a capital H and then a little 2 and then an O. So what do these things represent? They represent the number of atoms of that type of element in a molecule. So SQ2 has 2 squares together. TSQ2R has 1 triangle, 1 round one, and 2 squares. SQR3 has 1 square and 3 round ones, 3 circles, right? So that's what we are thinking about. I'm going to try and get through this last page. We're thinking about the codes right now. And I think what I'll do is I'll come back and do this page as a slightly separate video. I've got not much time left on this, so come back, see the next video, and I'll continue from here.